Now, let's go to question 5 then. This is part 2. Determine the equation of a straight line with a gradient of -3 and the points with the coordinates -4 and 6 on the straight line. So we are given the gradient, which is -3, and we are given 2 points -4 and 6. They require the equation of a straight line. Now we know that y equals mx plus c is the equation of a straight line. We have x and y. Gradient is -3, x is -4, which is -6. Y equals mx plus c. Plug in the value of m, leave your x, plug in the value of c, and 3 marks are given for that. Let's go to 5.2. Draw on a graph paper and on the same system of an axis the following graphs. So xy is equals to -2 and y is equals to -2x plus 2. Now, what is important for any graph that you draw? Let's try first to unravel this. So we know that xy equals -2, y equals -2 over x, right? And we are given an interval. We're drawing this from -3 to 3, right? So this would be the first one, and this would be the second one. So for every graph, we need to find the x and the y intercept. So in y equals -2 over x, x intercept y equals to 0. 0 equals -2 over x. And then can you see here, there is no x intercept, because when you cross multiply here, you're going to get 0 is equals to -2. So here no x intercept, right? Y intercept x is equals to 0. Y equals -2 over 0, which is error. So it is an asymptote there. So we also don't have no y intercept for this one. Right, let's check the other one. X intercept y equals to 0. Take to the side, divide both sides by -2. That is your x intercept. Y intercept x equals to 0. And then x intercept y equals to 0, and then y intercept x is equals to 0. Right, so here 1 is to 0 and 0 is to 2. Now let us try to draw this. X and y, 1 and 0, 2 and 0. That's fine. And then with a hyperbola, I don't have the x and the y intercept. So, but because the coefficient of the value of a is negative, it will be on the second quadrant. Please, I'm asking, right? I'm asking, please. They said we should draw this from -3 to 3. Now let's check something. If x is -3 here, I want you to see something here, because it will be on the second quadrant and on the third quadrant. Now let us check. On the second quadrant, the values of x are positive, so we're not going to try here with -3, -2 and -1, and we're not also going to try with 0, but we're going to try with 1. When x is 1, we get -2. When x is 1, we have minus 2. Minus 1, minus 2, minus 3, minus 4, minus 5. When x is 1, we have minus 2. When x is 2, we have minus 1. And when x is 3, we have minus, sorry, when x is 2, we have minus 1. When x is 3, we have minus 2 over 3, something around here, Alright, if we have something around there, let's check if this is making sense, because we are provided with an interval. This is one thing that I want you to see. We are provided with an interval from minus 3 to 3 as the values of the domain, as the values of x. So I'm saying here, because we want a corresponding value of y, and the value of a is negative, it must be on the second and also on the third quadrant. Therefore, we are saying when x is 1, you will get minus 2 as the value of y. When x is 1, minus 2. When x is 2, minus 1. And when x is 3, you will get minus this. So these are the points that we have. So remember, first, second, third, and fourth. Remember that. Sorry, first, second, third, and fourth. So it will be on the second quadrant. There it is. And also it will be on the fourth quadrant. There it is. First, second, third, and fourth. So second quadrant and the fourth quadrant. If it is positive, first quadrant, third quadrant. Please, second and fourth. So this is how it would look like. Right. And then they say in 5.3, given minus 2y minus x plus 8 equals to 0, determine the gradient and the y-intercept of the equation. Gradient and y-intercept. Let's rewrite this. This is what we get. So the gradient is minus 1/2, and y-intercept, which is c, is 4. Right. Let us continue and see what really transpires. Now we go to question 6. Now in question 6, this is what they gave us. Question 6, guys, it's going to take quite some time because there are some drawings that needs to be done. We have column A that we need to match with column B, and because you don't see visually what is happening here, I'm just going to skip this question 6 and I'm going to go straight to 6.2. In 6.2, given, this is what we have. 0.3, 0.4, M, N, P. Right, they say Mn equals this and Pn equals that. Calculate the length of MP using Pythagoras. So the hypotenuse squared is equals to Pn squared plus Nm squared. So 0.3 squared plus 0.4 squared, this is Pm squared PM equals the square root of 0.3 squared plus 0.4 squared, and you will just insert that on the calculator and find me an answer. Write down the trigonometric functions sine x, cos b, and tan c in terms of what is given here. So this is what is given: C 62, 28b, 90a, 12.35, and 40. So they want sine c. Sine c is opposite over hypotenuse. They also want cos b. Cos b, it's adjacent over the hypotenuse. Remember, the hypotenuse is the side which the angle of 90 points to, and they want the tangent of c. And the tan, it's opposite over adjacent, and you do not have this adjacent side, so you can find that adjacent side by just saying AC is equals to 14 squared minus 12.35 squared, and you will find that value and you will plug it in here. We don't have to do a lot of things there, right? So tan, it's opposite over adjacent, opposite over adjacent. You just find that value there, right? That is fine. Let's go to 7.2.1. In triangle DEF, we are told we don't know what that triangle is, but we can try and draw that. In triangle DEF, E is 90, DE is 43, and EF is 72. So E is 90, so this would be E, and they say DE is 43, so DE is 43 and EF is 72, right? And then calculate the magnitude of sine F. So they want sine of F, the sine of angle F. So the sine of F would be opposite over hypotenuse. I need to find the hypotenuse, which would be 72 squared plus 43 squared. So that would give you the hypotenuse. For example, suppose the hypotenuse is 74. I'm just making a probable example, so we would say 74 there, and then we would go to 7.2.2 and calculate the magnitude of cos D. Now the cosine of angle D, cos, remember it's adjacent over the hypotenuse, and you are done, right? Let's go to question 8. A cone is filled with peanuts. The radius of the cone is 6 centimeters and the perpendicular height is 10 centimeters. Right, calculate the volume of the cone. I think there are some formulas that are provided here. We are given cone. The formula there, it is a right cone, meaning it has a right, it forms an angle of 90. So the formula for volume of a right cone is equals to pi diameter squared divided by 4 times height divided by 3, or you can just say this is pi r squared h all over 3. I think this one is much better. A cone. Right, let's write down the data that is provided. We have pi. Do we have the radius? Yes, the radius is 6 squared. Perpendicular height is 10, and the SI units are the same, 6 centimeter and 10 centimeter. And I'm going to divide this by 3. Now you will find a value here in centimeter cube or cubic centimeters. Right, and then in 8.1.2 they say determine the diameter of the cone. Right, now what is the diameter? I know that the diameter is twice the radius, so diameter is 2 times the radius, so that would be 2 times 6, which is 12 centimeters as the diameter of that cone. Right, that is fine. Let's go to 8.2. In 8.2 they say the following. This is what we are given. There's a circle in here, and we need to find, I guess, the area of this. So we are given 28 meters. They say calculate the area of a square. So it's a square, all sides are equal. Now the area of a square is side by side. 28 by 28 would give you a value in meter squared. Right, that would be calculate the area of the square, and then they say calculate the area of the circle. Now remember the distance from here to there, it's 28 because it is a square. Therefore the radius is 1/2, which is 14 meters. So area would be pi r squared. Pi into 14 meter squared. That would give you a value in meter squared. And then in 8.2.3 calculate the area of the shaded portion or the sectionalized area. So what I would do there, because I want the area of the shaded region, I would take the area of the square. Suppose the value here you get is let me just make an example. Okay, let me just do it. Let me just do it. What is 28 by 28? We get 784. And what is pi times 14 squared? I get 196 pi. Right, these are the values that I get. So the area of the shaded region would be the area of a square minus the area of a circle, which is 784 meters squared minus 196 pi meters squared. And you would find the area of the shaded region. Very important. And then I think we are going to break it in here. When I come back, we would do, let me check what is left. What is left is it's something very simple. Let's just do it. 8.3. Calculate 12.7% of 1,596 rand 53 show all working. So they want 12.75% of means multiply 1596.53, and you just insert this on a calculator and you are done. 8.4. A lecturer bought a car for 205,000 and later sold it for 136,000. What was the loss in value of the car? So we have the amount that it was bought with, 205,000. We are subtracting 136,000. You just find the value that would be the loss, 8.4.2. Express the loss as a percentage. You would say 205,000. So meaning percentage decrease minus 136,000. I think you would divide this by 205,000 and you would multiply that by 100. That is how you find the percentage decrease. Let me just check the formula just to be sure. Let me go through the formula just to be sure. Just to be sure. Yes, I think I am sure. Then it will give you whatever the value that you would get there. And that will bring us to the end of our tutorial for N1. I will see you in another tutorial.